In the 20th century, no other invention affected the mankind more than technology did. With the advent of computers in 1950s and internet in 1990s, the fundamental way of doing things has gone through a massive change. These technologies made our lives better, opened up new avenues and possibilities, and gave us a hope for the future. But it generally takes decades for an ecosystem to be built across a particular technology, to take it to masses and achieve the truly disruptive nature of that technology. It is widely believed that 3D printing or additive manufacturing has the vast potential to become one of these technologies. Now, what really is this 3D printing that some have claimed will put an end to traditional manufacturing as we know it? Revolutionized design and imposed geopolitical, economic, social, demographic, and environmental implications to our everyday lives. The most basic differentiating principle behind 3D printing technology is that it is an additive manufacturing process. And this is indeed the key because 3D printing is radically different manufacturing method based on advanced technology that builds up parts additively in layers at the sub-millimeter scale. This is fundamentally different from any other existing traditional manufacturing techniques. Traditional manufacturing process has evolved a lot over time from hand-based manufacturing to the automated processes such as machining, casting, forming, and molding. Yet, these technologies all demand subtracting material from a larger block, whether to achieve the end product itself or to produce a tool for casting or molding processes. And this is a serious limitation within the overall manufacturing ecosystem. For many applications, traditional design and production processes impose a number of unacceptable constraints, including the expensive tooling, fixtures, and the need for assembly for complex parts. In addition, the subtractive manufacturing processes, such as machining, can result in up to 90% of the original block of material being wasted. In contrast, 3D printing process can create objects directly by adding material layer by layer in a variety of ways depending on the technology used. 3D printing is an enabling technology that encourages and drives innovation with unprecedented design freedom, while being a tool-less process that reduces prohibitive cost and lead times. Components can be designed specifically to avoid assembly requirement with intricate geometry and complex features created at no extra cost. 3D printing is also emerging as an energy-efficient technology that can provide environmental efficiencies in terms of both the manufacturing process itself, utilizing up to 90% of standard material, and throughout the product's operating life through lighter and stronger design. In recent years, 3D printing has gone beyond being an industrial prototyping and manufacturing process as the technology has become more accessible to small companies and even individuals. Previously, only big corporates used to own 3D printers, as the scale and economics of owning 3D printer make it prohibitive for smaller companies to own one. But with the rapid decline of the printer cost, the technology has become even more affordable. Nowadays, smaller and less capable 3D printers can be acquired for under $500. This has opened up the technology to a much wider audience, and as the exponential adoption rate continues on all fronts, more and more systems, materials, applications, services are emerging. In the coming lectures, we will discuss about various 3D printing processes in greater detail.